Hopefully you've had an opportunity to try this practice problem. I'm now going to walk through the solutions for you. So we're basically just balancing equations for a little bit more practice with this. So our first one has the C5H8 molecule reacting with H2 to form C5H12. So I'm first going to make sure my carbons are balanced, which they are. I've got 5 on my reactant side and 5 on my product side. And that was the most simple molecule to look at because it was just in one reactant and one product. Now I'm going to look at hydrogen, which is in all of the reactants and products. So it's a little bit more complicated. So on my reactant side, I'm going to take a tally of how many I have. I have 8 hydrogen from my reactant C5H8 plus 2 from my H2 for a total of 10. Now my C5H12, I have 12 hydrogen instead. So I really need 2 more on my reactant side. I'm not going to do anything to change the coefficient in front of the C5H8 because if I do, I'll have to then change the coefficient in front of my product, which will make me go back and change that, and it'll just be this spiral. So instead, I'm going to look at this molecule that has only hydrogen in it, H2. And so if I can get 2 more hydrogen atoms out of that, I don't have to change the number of carbons I have. So if I just multiply this by 2, I'll have 4 instead of 2. Now I have a total of 12 on my reactant side, and I have a balanced equation. All right, next we're looking at silver and elemental sulfur. And elemental sulfur is interesting because it's not just one atom or just 2 atoms. It's 8 atoms together in this structure. It's really cool. So I've got 1 silver, and I have 2 silver on my product side. So if I put a 2 in front of my silver, then I will have a balanced amount of silver. Great. Now I'll look at my sulfur. I have 8 sulfur on one side and only 1 on the other. So that's a little bit more complicated. So if I'm going to have 8 on my Ag2S side, my silver sulfide, then I'm going to need to multiply this by a coefficient of 8. Now I have 8 sulfur in my reactants and 8 sulfur in my product side, but this changes something when I come back and look at my silver. I now have 8 times 2 on my product side for 16 silver atoms, and I only have 2 on my reactant side. So I really need to change that coefficient in front of the sulfur. I need a total of 16, so I'm going to change it from a 2 to a 16. And then I would have a balanced equation that was 16 silver plus elemental sulfur forms 8 silver sulfides. All right, last one's a combustion problem. And looking at this one, I can see right away that the oxygen is pretty complicated because it is in absolutely every single one of my reactants and products. So I'm going to leave that for last and focus first on my carbon and hydrogen. So I have 7 carbon in my reactant side and only 1 in my product. So a coefficient of a 7 in front of my product, carbon dioxide, will balance out the number of carbons to be 7 on both sides. Now I've got 14 hydrogen on my reactant side and only 2 on my product side. So again, a coefficient of 7 will make 7 times 2 or 14 hydrogen on my product side to match the 14 hydrogen on my reactant side. All right. So that was pretty straightforward. Now let's figure out this oxygen piece. Right now, I'm going to start by looking at the amount of oxygen I have on my product side. So I have from my carbon dioxide 7 times 2 oxygen, so that's 14. And on my water, I've got 7 times 1 for 7 oxygen. That's going to give me a total of 21 oxygen on my product side. Now, looking at my reactants, I have oxygen incorporated into the carbon and hydrogen molecule. And if I change this coefficient in front of the carbon and hydrogen oxygen molecule, I will have to go rebalance the carbon dioxide in the water, which I don't want to do. So I'm going to leave that one alone, and I'm going to balance using the oxygen that's totally by itself. Now, I need a total of 21 oxygen on my reactant side, but I already have 2 in one of my molecules. So I'm going to take that 21 minus the 2 that is part of C7H14O2, and that's going to give me 19. That remain. And so I need 19 oxygen atoms from my oxygen, molecular oxygen, O2. But 19 is not an even number. And so for each of these molecules, there's 2 oxygen in it. So I really need to have 19 divided by 2 O2 molecules to create 19 oxygen atoms. So that balances it. Right now, this is a balanced equation, but this is not an equation that has whole numbers. That 19 divided by 2 is going to become 9.5, which can't have half of an oxygen molecule. So what I do to solve this problem is I multiply everything, all of my coefficients, by 2. And I'm multiplying it by the denominator that is in my fraction for my coefficient. And so that 2 is going to distribute out to all of my coefficients, making that 7 of 14, this 7 of 14. This becomes a 19, and I get a 2 in front of my C7H14O2. And now I have a balanced equation. So I can rewrite that as, just to clean this up, make this a 2. This is now a 19. I have a 14 and another 14. And now I have a balanced equation.